Okay, this is for honors inverse matrix proof. To begin with, let's take a look at remembering what inverse means. So with the general case of inverse, we have like A times the inverse of A will equal 1. Very similar to this with a matrix. If I have a matrix B and I times it by the inverse of that matrix, I'll get 1. And for a 2 by 2, that looks like 1, 0, 0, 1. Of course, we can do more complicated than that, but for now, we're not going to. So our task today is to figure out what goes in here. Okay, so I've set up um, a matrix here, A, B, C, and D. And we will go ahead and just fill it out. So we want to times it by E, F, G, and H, such that the answer gives us the identity of 1001. So we start out with the first one, A times E plus B times G, and that results in 1, going right over here. Then we'll go ahead into the next row, C times E plus D times G equals the result over here of 0. Continue on the other way, so we have the first row, A times the second column, A times F plus B times H, that equals 0. And then we have second row, second column, results in 1. Okay, so the first thing that we're going to do is we want to find out what E is about. Okay, we're going to try to solve for E. And we'll notice that E is only in these two equations, so we'll form a system and we'll eliminate G. So to eliminate G, I'm going to multiply each statement by the coefficient, the one before. And I'll also notice that I want it to, when I add them together, eliminate. So I'll go ahead and make this negative. So now I get A, D, E plus B, no, D, G equals D. Then negative BCE minus BDG equals 0. Add these together. G is indeed canceled out, leaving us with ADE minus BCE, and all that equals D. Now remember, we're trying to find E, so let's factor it out, giving us AD minus BC times E equals D. And we need to get E by itself, so we'll divide both sides by AD minus BC, so divide everything by that. And that results in our first element of D over AD minus BC. Okay, now I'm going to proceed with the others, doing the same thing and putting in the respective places. I am going to try and high speed it so you can just zoom through and see what's going on. Okay, so that lets us, that gives us the formula here. Now we go ahead and take this information and we notice that all of these are the same. So we can factor it out having 1 over A times D minus B times C multiplied by D minus B minus C and A. So this results in the inverse matrix formula. So just to show it, we take A, B, C, and D. We take those numbers that are in that place. And to get the inverse, we apply it to the formula for the inverse. Now, the trick is we just swap A and D, and we change the sign of B and C. And remember that we also want to check if the determinant, which is the denominator of the fraction in this formula, to see if there is an inverse. So, as you may recall, if there is a 0 on the bottom of this fraction, it makes it undefined, and therefore there is no inverse. There you go, and happy mathing.